Titrations in practice. Titration is a method of analysis used to determine the concentration of a substance, often an acid or base. Where do we find titrations? They are widely used in the wine industry to determine the total acidity and sulfur content of a wine. In the food industry, they are used to determine the concentration of vitamin C or E. And in the pharmaceutical industry, they are used to adjust the dose of a drug in a medication. So these and other types of titrations have wide-ranging applications and importance. Some of the equipment or apparatus is shown here. I'll introduce the major pieces, not all of these, one at a time. First is the burette. It has gradations on it that allow you to measure quite accurately up to 50 milliliters of solution. It's held in place by a clamp, also called a burette clamp. The bottom part is called a stopcock or a tap. In this position, where the blue bar is horizontal, this is the off position and liquid cannot flow through it. When it's turned to the vertical position, then fluid can flow through it. The gradations are to be read in a downward manner. For example, if the liquid level falls from, say, 0 to 2 milliliters, that means 2 milliliters have come out from the tip at the bottom. Next, this is how the burette and the Erlenmeyer flask are positioned together. The tip of the burette must be clearly below the neck of the flask. The name Erlenmeyer comes from a German chemist, Emil Erlenmeyer, who invented this flask in 1860. Because it has a conical shape, it is also called a conical flask. So conical flask and Erlenmeyer flask are the same thing. In order to add liquid to the burette, we will need a funnel like this. A pipette is a highly accurate device that measures and delivers an exact volume of liquid when used correctly. This one is a 10 milliliter pipette, but there are others. Most commonly, we use a 25 milliliter pipette for a simple acid-base titration. This picture shows a pipette delivering liquid into a flask. If this pipette is not available, a graduated pipette can be used. Finally, we need to have an indicator for any titration. The most common one for acid-base titrations is called phenolphthalein. These are the main pieces of apparatus or equipment for a typical titration. Now, the first step is to fill a burette with sodium hydroxide solution of known concentration. That is, its concentration was previously determined. This titrant, as it is called, doesn't have to be sodium hydroxide. It will depend on what kind of titration you're doing. For this example of an acid-base titration, sodium hydroxide is being used as the titrant. A funnel is used. Notice how it is lifted slightly. This is so that we don't get blockage of the liquid at the top of the burette. Make sure the stopcock at the bottom is closed before you start this. The sodium hydroxide is poured up to roughly the 0 milliliter mark. It doesn't have to be exactly at 0, but we do have to record the exact volume as our initial reading. Step 2, transfer 25 milliliters of the acid whose concentration we want to determine into the Erlenmeyer flask. At the top here, the person is holding a pipette pump, which is used to draw the liquid up into the pipette. The details of how to use a pump or a rubber bulb will be shown by the instructor once you get into the lab. Here's a demonstration of its use. He's showing here how the wheel is rolled to draw the liquid up into the pipette. Pointing now to the mark that indicates exactly 25 milliliters. So using the wheel, the liquid is drawn up to the mark. The solution is then released. There's a better way of doing this, but this will work. And at the end, the tip of the pipette is touched against the side of the flask and then moved away. The small amount left in the tip is meant to stay there, so that exactly 25 milliliters will flow into the Erlenmeyer flask. The third step is to add a few drops of the indicator solution. He has phenolphthalein in his hand. It remains colorless in the acid. The indicator could also have been added before placing the flask under the burette. The flask should be placed so that the tip of the burette is well inside the neck of the flask. Looking at this version now shows how to manipulate the stopcock or tap. If you're right-handed, your left hand will go around the stopcock like this, and with the right hand holding the neck of the flask, a little movement with your wrist causes a nice swirl. If you're left-handed, turn the burette around and manipulate it with your right hand. With practice, this method allows you to titrate constantly, slowly or quickly as you like, without having to stop and start frequently. Here is an example of the titration near the endpoint. Initially, you allow the titrant in quickly because you've already done a rough titration that tells you how far to go quickly before slowing down. But when you get near the end, you can actually allow just one drop at a time. Swirl in between until you get the faintest pink color, and at that point you have reached the end point and the end of the titration. Here's another example showing how to do it without gloves. Whether you use gloves or not will be decided by your instructor or teacher. The fingers are clearly seen around the tap, controlling it in the off and on positions. The right hand is holding the flask at the neck where a good swirling action can be made. This shows good titrating technique. This is not a good technique. It is both awkward and inefficient going back and forth like this. Sliding the flask back and forth is not quite as bad, but it's still more awkward than a nice swirl from the neck. With the titration complete, we need to read the level of the liquid in the burette. Going back to the beginning, recall this picture. The level of sodium hydroxide, reading from the bottom of the meniscus, is between 2 and 3 milliliters. But we have to read it downward. So this is about 2.9 milliliters. At the end of the titration, you can see it's just below 19 milliliters. Although it's not clear here, let's estimate the level to be 19.2 milliliters. The volume of sodium hydroxide delivered into the flask is simply the difference between these two, so you subtract them and we get 16.3 milliliters of sodium hydroxide. We also have 25 milliliters of acid that was titrated to the end point. This kind of titration should be done at least twice and preferably 3 times. If one titration goes awry for whatever reason, just do another one. There's no limit to how many you can do. The idea is to get 3 results within 2 to 3 milliliters of each other. This consistency provides assurance that your titrations were precise. Remember that after the first titration, the liquid in the flask, now neutralized, must be discarded, then rinsed out, and another 25 milliliters of acid must be pipetted into it for the next titration. This is done for however many titrations you do. Finally, what if you need to determine the concentration of a base instead of an acid? Here is the setup. The acid in the burette is of known concentration, and the flask contains an exact volume, 20 or 25 milliliters of the base. This time a different indicator, called bromthiamyl blue, is used. Its color in the base is blue, and the end point is reached when the blue turns to a faint yellow color. Here is a short clip to illustrate. So now he's just gone past the end point just to show clearly the yellow color. How to use this data to determine the concentration of the acid or the base is the subject of the next video, but I hope this one gives you a good idea of what to expect and what to do when you get to do your first titration.